The broadcast is now starting. All attendees are in listen-only mode.
Welcome, ladies and gentlemen, on today's webinar organized by SEA and title SEA Engineer 18 links with Tekla structures and Revit. My name is Jaroslav Broz and I'm product manager responsible for BIM and these links. Let me start with presentation. Before we will go to the details, I would like to mention some housekeeping rules. So how to using the GoToMeeting. You are in listening mode and audio is muted. If you would like to ask a question, you can, and you can use this question box. The webinar is recorded and will be placed on our YouTube channel. And now let's start with our theme, which is related to the BIM. And I would like to mention at the beginning what, let's say, the holy grail of BIM and what could they mean. That could be the abbreviation for better information modeling. Because in the real practice in the past, you had an architect, civil structure engineer, and some other parties involved in the project, and everyone can communicate with others, sending some mails, some files, and it could be very messy, and you can lose some information. With BIM, it could be better that you have some shared model and everyone is connected to this model, and all necessary information are sent to this model, and this should be, let's say, the holy grail of the BIM for better information management, and we are aware of it. Therefore, we are developing the links with other softwares like Tekla Structures and Revit. But there is also one thing which should be, let's say, clarified, and that you can map, let's say, the three models in the practice. The first one, that's the architecture model created with an architect in CAD software with all the details like furniture, cars, trees, people, etc. The middle one, the figure, is related to the structural model where you have some objects. All the architectural details are removed, but it's still not what the designer needs to have for his work. And that's the last model, which is an analytical model, and that's the representation of the model with 2D and 1D elements as we are used to in our daily practice. I would like to concentrate here on the two softwares, Tekla Structures and Revit. Both of these softwares are able to create the last model, which is the analytical model, and we will work with this model in our webinar. So let's start with the first link, which is related to the Tekla Structures. And before we will go to the details, I would like to ask you a very simple question, and that's it. Do you use Tekla Structures in your daily practice? You should be able to see the full link, so you can vote. I will let it 1 or 2 minutes. So I will let you vote. The votes are still changing. Now it's stable. Okay, so the answer is that 54% of you are using Tekla structures in the daily practice. So you will be happy that we improve our link with Tekla structures. And I would like to mention some, let's say, top features compared to the old solution. The first one, and then the most important, is that it's a bidirectional link, which means that it supports transfer from Tekla structures to STEA Engineer and from STEA Engineer to Tekla structures back to the one link, as we will see in my presentation. The next thing which is related to the link is supporting of mapping tables. And based on the building standard which you can use, you have some predefined mapping tables. The third top feature, at least for me, that's the possibility of export of results from STEA Engineer to Tekla structures for some other use, for example, for design of connections. And the last one, that's the possibility that you can use direct link, which means that you have Tekla structures and STEA Engineer on one computer, and you are able to run STEA Engineer directly from Tekla structures, or you can create a file in Tekla structures or in STEA Engineer and send it to your colleague, which can use it for his design afterwards in Tekla or in STEA Engineer, respectively. I will continue with some workflow which I have in my head when I'm thinking about the workflow Tekla structures and STEA Engineer. So the first thing is that you create a structural model in Tekla. Then you, based on the structural model, you create analytical model with the help of Tekla. Then you export this analytical model to STEA Engineer, run analysis, do some design, if necessary, do some changes in the case of the profiles, concrete grade or steel grade, recalculate it, and then export it back to Tekla. That's let's say for me as an ideal workflow in Tekla structures and STEA Engineer. Here is what is currently supported in our link with Tekla structures, and that's the mapping of cross-section and materials based on the Eurocode building standard and British standard. Based on that, you are also able to import or export straight and curved 1D members, and import or export flat 2D members without openings. As I mentioned, that we are able to export or import analytical model. So you are able to export, import supports or releases and rigid arms. And last but not least, you are able to export results from the engineer to Tekla structures. And now it's time for the live demo in Tekla structures. So I will switch to the Tekla structures. I hope you see my structure, which I get from my colleague, and it's the concrete as well as steel. I have 1D and 2D members. I have here also some bracings, and what I would like to do is to export this model from Tekla to the engineer. What I need to do at the beginning is to create an analytical model. So you can, if you are used to do it here, I have it prepared. There is several options how you can do the analytical model, and what's important is that you should pay attention to the member axis location to get really the proper analytical model in the engineer. So I have it defined my analytical model as you see on the background, and now I can just open the menu application component. I will start typing there, and with double click I will see the dialog with the options. So as I mentioned, I am able to select the national code, British standard, or Eurocode, and I can also select the version of the engineer. I will try the last version of the engineer 18 and the 64-bit edition, and I will use the direct mode of the transfer. I will export the full model and I will export it as a new project. Here I have the possibilities to create my mapping. I'm able to do it for materials. So here you can see what I already mapped. So material in Tekla structures and material in engineer. The same I can do also for cross sections, that I'm able to see that I map this L profile to that profile in the engineer. That's it. If you have no mapping tables, then you will be asked during the export to create a mapping with simple dialog. So I will push the button export to engineer. On the background, there is a translation which reads the analysis part defined in Tekla structures. It will take some time. And now in this window, you can see the status was currently transferred. Here you can see the mapping that it asked me I need to map this element. So I already did it, save it, And now it's starting Steer Engineer, opening the project in Steer Engineer. And here on the last line, you can see that it creates some file in the folder on the background. So you can also open it if you want. So here I have my engineer. I will wait for some analysis of cross sections for the members, and we will be able in a couple of seconds to see the whole structure. When I will have my structure in engineer, I will enlarge my view, and you can see that everything what I have in Tekla was exported, and I'm able to see it in the engineer. I have here one load case that's self-weight, and here, if I will go to the service structure, I have also supports which I already defined in Tekla structures. And now I can run the calculation, and I will get the results back. And before linear calculation, I will wait on the results. So, okay, almost done. Okay, so I have calculated results for sulfate. I will, for example, I will display the results for 1D internal forces for normal force. And now, as I have done what I need to in the engineer, I will go back to the Tekla structures, to the dialog, and I will push import from the engineer. On the background, it will read the engineer project, and then it will transform it to the Tekla structures. It's mapping materials, and as I said, that I'm able to export also results coming from the engineer. There is a dialog where I can select the type of load, and as I defined just load case for the demonstration purposes, I will select the load case, and I have just one, so it's LC1 self-weight. I will push OK, and now the module in Tekla structures is updated with all the possible changes which I could do in the engineer plus selected result. So I will wait until the export is finished, and as you can see here, you have all the necessary information what is going on the background. You can see also the progress that saying that it's updating, and now it's reading results, updating support conditions. So we are, I think, in 2/3 of the export, as I can see it on the progress bar. So I will wait. So everything is done successfully. Here you can also see which entities have been exported, with how many of them failed and ignored. I will close the report and I will switch back to Tekla structure. And the question is how should I check, for example, the end reaction? So I will pick this column, and here in the custom properties, I have an option more. I will click on the more, and here, okay, doesn't do anything. Normally, you will see it here in the end conditions. So that's pity that I wasn't able to demonstrate it. What's also possible is, if I will go back to the engineer, is that, for example, I will change cross section of this column from 260 to the new one, for example, 400. Okay, close. Okay, I will erase all the calculated results. So here I did a change, and now I would like to propagate it to Tekla structures. So I will run export, and before I do it, I have no results, so I will cancel the selection. As you can see, the section 400 is mapped, and now the model is updated. I will switch it back here. You can see that the profile changed, and that's all what I would like to share with you related to Tekla structures, and we will continue with Revit. I'll go back to my presentation as I did it for Tekla structures. I would like to ask you if you use Revit in your daily practice. Let's take 2 or 3 minutes for collecting responses. And meanwhile, I will also have a look on questions. So it seems that no one is voting what are okay. It's similar to the Tekla, and it's the 41% saying no and 59% is saying yes. That's nice, and I will continue in my presentation. For me, let's say the top features for Revit structure is mapping tables. That's the possibility to map materials and cross-sections in Revit to materials and cross-sections in Engineer. That's also the possibility of the usage of direct link or the possibility to create a file for your colleague. Export results from Engineer, and also the possibility just update the profile where the geometry is kept, which means that you can slightly move column or beam in your analytical model in Engineer, and then during the update from Engineer to Revit, you can just select that you would like to update just the profile or just the size of the member. As in the case of Tekla structures, the ideal workflow, at least for me, it's starting with the creation of a structural model in the Revit. As you know, Revit is able to create an analytical model. Then you are able to export Revit model to Engineer, do the analysis, necessary design. You can export it back to Revit and do the update. So that's perfectly possible to do the round tripping. What's currently supported in our link, that as I already mentioned, mapping of cross-sections and materials, possibility of import 1D as well as flat 2D members, import and export of foundations and support, and import and export of load, as I already mentioned, export of results. And what's really the new in the link, which is contained in Engineer 18, that's the possibility of export reinforcement for 1D as well as 2D members. We will see it on the next slide. So you can do the reinforcement of design in Engineer. You can create the real reinforcement or the practical reinforcement in Engineer, and then you can export it to Revit and do the detailing. That's one thing what's really new. And as you are used to, there are some fixes and more enhancements, which, for example, that's the mapping improvement. So we are able to directly through the button on the ribbon go to the mapping and do some adjustments. As I already mentioned, that's the possibility of update member size only. It means that there is no change of the geometry in the Revit, but just the member properties as a cross-section. What also enhanced, that's the possibility of import-export partial and trapezoidal load, and in the case of the composite and virtual joist, that's the number of basic and number of spaces and concentrated load. And as I did it for Tekla structures, now it's the time for the demo. So I will switch to the Revit. Here I have my structure created in Revit. That's the, let's say, composition of the concrete and steel part. And what I, for example, would like to do, I will switch to the analytical model, and for example, on the analysis for step 5, will define the trapezoidal load into the load case light load 1. I will use the hosted one, and it will be, as I said, trapezoidal, and will go from 1 kilonewton to meter to 4. Okay, that's not what I originally wanted. I will delete it and do it once again. Yes, that's what I wanted to demonstrate. So I have my analytical model with some support conditions and with the load, and I would like to export it to the engineer. Here, that's the possibility how I can do it. That's the well-known dialog for export of models from CiEngineer to Revit. And what also here new, and what wasn't mentioned during my presentation, that's the possibility that you can create levels in Revit based on some data or the work which you will do or did in CiEngineer, and that's the definition of levels based on the, let's say, slab surfaces or slab levels, or based on the stories which you will create in CiEngineer, or the last option that you already defined Revit levels. So I will export model from Revit to Engineer. Here it's the dialog for export on the background. It's reading analytical model in Revit and preparing and transforming to the analytical model in the Engineer. So here you can see how many structural columns, structural framing, which is in fact beams, load combination, load cases, boundary conditions, just as there are. Now you can see also which materials are used and met. That, for example, the default wall material is mapped as concrete grade 2025 based on my mapping. So export to the engineer is done. I will close this dialog and I will switch to engineer. So here is it. I will use this rendered form of the display. So as you can see, all what I defined in Revit is exported. 1D, 2D members support. If I will go to the load, you will see that I define the trapezoidal load in the load case, so like load 1, and here it's displayed. So I can run the calculation, do the design, and for example, what I would like to also show you beside the reinforcement is also the possibility to export load panels or rigid diaphragms. So for example, as a designer, I would like to create some roof here on the top of the structure. So I will go to the members lathe, and I would like to create this metal deck. So I will select the sheeting. Okay, and now I can create this very nice roof. And now I can continue with addition of the load on the top of this diaphragm. It will be transferred, as you can see here, to the tributary areas on the supporting elements. So imagine that I did it, and now I would like to also reinforce my structure. So I will go to the concrete and I will start directly with the input of the reinforcement. So I will go here for the 1D members. The select. I will click on the new reinforcement. I will select the member. So I will select the column, start point, end point, and I will select some predefined template for reinforcement. Let's say that it will be this one. I will accept it as it is, and now I will switch it to the wireframe model to see my created reinforcement. I will do the same also for beam, and for beam I will select this kind of template. Okay. Accept what is offered. So I reinforced this column and the beam, and what more, I would like to reinforce also this slat. I will just use the bars with this material on the level surface. I will accept everything what's written here, and I will start the creation of the region. So I will create it. Okay. So for example, I will. Sorry for that. I'm not so skilled designer of concrete. So be patient with my uh, style. So I hope that I have everything what I wanted, and I would like to no, still not. Sufficient. So I'll okay. So I was successful. Thank you for your patience uh, with my effort. So here you can see the region with 2D reinforcement and with 1D reinforcement, and I will go to the Revit, and I will start import from the engineering. Now it's reading all what I defined in the engineer, all the loads, all the combinations which are created. It's also asking about the mapping of reinforcement steel. So I will use what's proposed. I will save it, and now it should continue. Okay, so we will see also the mapping of rebars of the diameter 10 to the Revit rebar type 10BE, etc. On the left hand side, you can also see the actual status of the export, what's imported, what isn't imported. In fact, I just created one load case in the engineer, which is a self-played load case. The 9 load cases have been already created in advance in Revit structures. What I didn't do and what I haven't is that I haven't the profile family for sheeting, which I selected in the engineer. And here, as you can see, I'm get a warning that that's not what is available, let's say, in my installation. On the below, you can see that I have some area reinforcement, I have some tilt and longitudinal reinforcement, and what's mapped, and also the time which I spent. So let's close. What I would like to do, I would like to see just the um, reinforcement, for example. So here is the QD, and if I will be successful in switching all the things which I would like, wouldn't see. Okay, so here you can see that here is reinforcement for column with longitudinal bars and stirrups, and the same is also possible for beams. And if I will click on the rebar, that's the real, let's say, Revit rebar. So you can use all the detailing tools which you have in Revit application. And as you may notice, when I started in the Revit, here wasn't any 2D element, and now there is an element which I defined in the engineer as a metal deck, or so-called flexible diaphragm. This possibility is also possible for our load panel. So if you create load panel in the engineer, in menu structure, here, that's also what could be exported from the engineer to Revit. So here you can see my metal deck that I selected as a one-way slab with all the things related as a material and information about the load. About the sheeting. And I will go back to my presentation. So we had the Revit structure link live demo, and that's it what I wanted to present to you. Now we have still, I think, 10 minutes for your questions. So I would like to ask you to send these questions, and we can answer it. All the time when I have been speaking, my colleague Janes has been so kind and just typing all the answers. And I think that now time to switch it from the typing to the explaining. Uh, so I will start the reading of the questions which are not yet answered, and we will answer it. And I will select the question, what should be analytical auto detect horizontal and vertical in Revit by default is 300 millimeters, and I'm afraid that I'm not able to answer your question as I'm not an expert for Revit. But what I can recommend is that you can play uh, play with it to see the effect of the transforming of the model from structural to analytical and then to the steer engineer. And that's here some addenda to the question. With 300, our analytical slab edges are often zigzag because the slab edges tries to connect with the center of the column if they are different sides. Yeah. As I said, it needs to be discovered. And what also the reality is that the export or the conversion of one module to the another one, sometimes it can happen that not everything is as it should be. Therefore, you should check your model after the transfer to Stia, the engineer, how it looks and what's the behavior. One of the options which we have is also the testing of the input data in the engineer that it should let you know if everything is correctly connected. There is also question, I can see the gap between the wall and curved beam. How do you explain it? I think that you mean that's the basically what I think was also the previous question, and that's let's say the problem with the creation of the curved edge and the curved element underneath. And I think that you should be able to improve it. And I think that if you will ask one of our experts on uh, technical support in our customer connecting, they should be able to help you to refine it and to select it. Um, I will read some other questions as we have 5 minutes. Uh, there is a question: can the rebars imported from STL be scheduled in Revit schedules? Uh, yes, as it is the Revit native native object. I hope that you are able to just click here in schedules quantities and then do what you are used to do it. And as you may notice, the providers of the link are the cat, and they have their tools for the detailing in Revit. So that's already possible. Um, I think we have for minutes all the questions which are not yet answered will be answered through the mails if that's possible. And here is a question: when's the engineer going to connect and do the things with Vectorworks, which is a Nemetschek product, rather than using Revit? To be honest, we are orienting ourselves on the Revit and Tekla, as they are, let's say, used a lot in the Europe also, and that's the CAD-like, or in the case of the Tekla structures, that's also the fabrication software. And in the case of, for example, Vectorworks or Allplan or any other CAD software, we are able to import and export IFC file. So here, as you can see, we are able to import IFC 2x4, where we are certified, and then the same possibility is valid for IFC 2x4 compressed. In the case of the Allplan, there are some special rules on the background. And you mentioned the Nemetschek product. That's also, for example, SDS2, and you can see here that we are able to export it to SDS2. So we haven't any particular connector or link with Vectorworks, but you can do it to IFC, and that's, for example, the same for Archicad. We are at the end of our webinar. I would like to thank you for your attendance. Have a nice rest of the day. As I said at the beginning, this recording will be published on our channel. Thank you and have a nice rest of the day.